me, this technology, the basis, right, it's the same, but if you want to make it usable, valuable, and reliable for business, it's a completely different stuff. You know, with business, there are problems connected, for example, to data properties and IP that you can ignore in a consumer environment, but you cannot ignore in a business. If I use a model, okay, or a big language model that is contaminated by IP directly or indirectly, you know, it's like I'm stealing IP of another in the business. So when we try to create a technology that has impact on me, we have to take care about of this. So that is why, for example, we do have a super hyper focus that others doesn't have on dynamic AI governance.
Are you concerned that those other elements can detract on the bubble factor might detract on what you're trying to
do? Look, we cannot change what everybody else is doing or what the world is doing, but what we want to do is to develop the technology, and when I say technology, it goes from the base infrastructure to the middleware, to the hybrid cloud, to the model itself, to all the pieces to be able to deliver this AI to the business in the right way. But again, we are only at the beginning. What we are seeing today as a business impact is mainly on back office and automation and IT ops automation, right? So I can use this to make the life of a programmer more effective, the HR of my company more effective, chatbots is more effective. That are the easy things, and that are not easy, but is what everybody is trying to monetize today is able to do. What I showed you before is the next step. So if you are using it for other modalities, if you are using it to try to impact the algorithmic layer and so on and so forth. So it's more an AI that goes to the core business. A pharma company, the core business is to develop drugs, right? Not to write reports. The core business is that. A materials company or a chemical company is to develop polymers and materials. So what I was trying to do, to tell you before, is that there is this new wave with these new foundation models, and the new foundational models could impact much larger use cases, but if you try to use it to change abstraction, the impact is going to be much, much larger, and there is not a winner today. Many are starting. We have started a couple of years ago in doing these type of things, and for example, on the geospatial, I believe that there is nobody else that has geospatial models that goes from the big to the small, that are using all of the scales, thanks to our partnership with NASA and the ESA today. To give you an example, right? Is a I would say more a niche field, but is a field that is going to be a big impact in the future. Second thing is on quantum. Quantum, frankly, we have invested under the cover since probably 60 years or more, since the beginning. Some of the key theory and even the theorization of universal quantum computing was done by an IBM researcher, David DiVincenzo. We have came out, you know, with some of the first early application 30 years ago, right, using quantum and NMR. And the past 10 years, the technology has matured so quickly, and we have put a big emphasis on that for different reasons, but a big emphasis is our part connected to the future, that I do frankly believe that today the world is divided on quantum, is divided in two sub-worlds. A world of people that are still working, developing, doing research on devices that you cannot call it quantum computers, are devices, prototypes that are useful for the initial development and eventually the development of additional new technologies in quantum. And there are many players, startups, but not only startups, right? And then there is a world where there are only very few players were they to say, we are entering the era of quantum computing. What does it mean? That you have not devices, you have many of these devices, very coherent, stable enough, with a roadmap, and definitely devices that already today you cannot simulate or emulate anymore with a classical computer. Okay, so this is the area of the 100 plus qubit that with an error rate that you know is lower than 1 10 to the minus 3 on the 2 qubits error rate, right, approaching the 10 to the minus 4, so 1 error on 10,000, that allow you to do at least 5,000 operations before the machine is not quantum anymore. In this area, right, I do believe that there are only 3 players today. Only 3 that are in this area that I will call the area of initial quantum computing. One is ourselves. Second one is Google. The third one is the Chinese Academy of Science. To be very blunt, okay? So, I do believe that on this one, we do have probably a couple of years or more advantage to the second one, but you know, the ones that are much more near are the ones that I mentioned. By the way, not by chances, all the 3 that I mentioned are based on the same initial key technology that is superconducting qubits. Okay?
Thank you.